By mid-morning, in many companies, several different artificial intelligence tools are already helping people make decisions. A sales lead is pasting a red-lined contract into one browser-based assistant. An engineer is asking another tool to draft a new interface. A marketing manager is quietly workshopping copy in an app on a personal laptop.
None of these tools went through procurement. None went through a security review. They began as experiments, then never really ended.
This is the world of LLM Roulette, when every employee has a different AI in their browser. A Wednesday headline feature from Bare Metal Cyber Magazine, developed by Bare Metal Cyber.
In this story, we are talking about what happens when artificial intelligence does not arrive as one big enterprise platform. Instead, it arrives as tabs, extensions, sidebars, plugins, and personal assistants that employees adopt because they are useful, impressive, and available.
Over time, those personal co-pilots stop being toys. They become part of how work actually gets done. They shape tone, speed, judgment, and risk appetite, often without any deliberate design from leadership.
Walk through most organizations today, and you can see this shadow layer in plain sight. Marketing teams use favorite writing assistants and image generators. Finance analysts use whichever tool summarizes vendor decks the fastest. Product managers paste user feedback into whichever model clusters it cleanly.
To the people doing the work, this does not feel like a new system. It feels like saving 10 minutes here and an hour there.
From a security and technology leadership perspective, those small choices add up to something much bigger. Each assistant has its own data handling rules, retention practices, training policies, plugins, and identity model. Some are tied to corporate single sign-on. Some are tied to personal email. Some are tied to social logins no one remembers approving.
Instead of one managed enterprise AI deployment, you now have a loose constellation of decision helpers sitting at the edge of your environment. They are ingesting sensitive context and emitting business decisions.
That quiet expansion changes expectations too. Once people get used to an AI helper that drafts emails, reviews documents, writes code, or summarizes meetings, they build that speed into their promises. Project plans and stakeholder expectations begin to assume an AI boost, even though the organization never formally decided to rely on it.
When someone changes roles or leaves the company, they do not hand over a supported system. They hand over bookmarks and tips. Use this one for contract language. Use that one for code. This model is better for customer emails.
Critical workflows become embedded in personal AI setups that leaders did not design and cannot easily reproduce.
The real issue is not only how many tools the organization has, it is how many different brains are steering the organization.
Each major large language model has its own training data, alignment choices, guardrails, and failure patterns. Some tools are cautious and verbose. Others are terse and speculative. Some hallucinate confidently in narrow domains. Others refuse when the input is unclear.
When employees use different tools to make similar decisions, the company is effectively running parallel decision engines.
You can see this most clearly in work that depends on judgment. A customer success manager asks one tool to rewrite a difficult email and gets a calm, de-escalating response. Another employee, using a different tool, gets a more aggressive upsell tone that may help short-term revenue but damage trust.
A policy analyst using one assistant may receive language that stays close to internal standards. Another may receive language that quietly blends company rules with generic public guidance. Over time, customer communications, internal memos,
policies and reports begin to drift.
That drift is not just stylistic. It affects risk posture.
Some AI tools push users towards aggressive automation and optimistic interpretations of policy. Others nudge people towards slow, heavily caveated decisions. If one engineering team uses a model that generates brittle shortcuts, while another uses a model that constantly flags edge cases and safety concerns, you are no longer managing one engineering culture. You are managing several, each with a different default setting for risk and quality. Accountability becomes blurry. When something goes wrong and someone says, "That is what the AI suggested," it can be hard to unpack what happened.
Was the suggestion shaped by the vendor's default configuration, by the employee's prompt, by a third-party plugin, by internal tuning, by the model's training data? If you do not know which AI system was in play and how it tends to behave, after-action reviews turn into guesswork. The organization cannot easily learn from mistakes because the decision logic is inconsistent and opaque.
Underneath this is a hidden integration tax. Every time someone connects an AI assistant to email, calendars, ticketing systems, customer records, documents, or code repositories, they create a new integration without an architecture review.
There may be no diagram, no change ticket, and no formal owner. There may only be a browser extension that reads page contents, a sidebar that pulls in meeting context, or a connect your data wizard someone clicked through between calls. Each connection may seem reasonable on its own. Together, they form a parallel integration landscape that monitoring and governance were never designed to handle. That means important activity may happen where there is no logging, no policy hook, and no clear ownership. A browser extension can see the same information as a reviewed application integration, but send events to a backend the organization does not control.
During an incident, security teams may trace data through core platforms, but have almost no visibility into what third-party assistants saw, cached, or learned from the same material.
This hidden tax also affects resilience and change management. When a core system changes, leaders usually know which downstream services to test and notify. With ad hoc AI connections, dependencies are implicit and brittle. A small change to support ticket formatting, record tagging, or document structure may quietly break someone's AI-powered workflow. The employee may not open a ticket. They may simply stop trusting the system and move to another tool. That behavior makes standardization harder because the lived experience of what works fragments across teams and tools. The alternative to LLM Roulette is not one rigid model for everything. The better answer is a reference architecture that treats AI as a deliberate part of how people, data, and systems interact.
In practice, that usually means 2 lanes. One lane covers centrally governed AI capabilities for high-risk and high-volume workflows. These are areas where the organization needs consistency, auditability, known model behavior, and strong data controls.
The second lane covers clearly bounded experimentation. Employees still get room to explore useful tools, but inside rules that define what data is allowed, what is off-limits, and when an experiment must move into a governed path. The goal is not to standardize curiosity out of existence. The goal is to standardize the places where important decisions are made. Many leaders are exploring an AI gateway as the backbone of that design. Instead of letting every extension call whatever model it wants, requests flow through a broker that understands enterprise identity, enforces data policies, and collects useful telemetry. Behind that gateway, the organization maintains an approved catalog of models and configurations, tuned to real use cases. At the edge, Employees may still feel like they are using AI in the browser. Behind the scenes, they are being steered towards engines with known behavior, instead of treating every tab as an independent system of record.
Data zoning matters just as much. Sensitive customer records, regulated data sets, confidential strategy material, and live incident data should only be reachable through pathways that enforce residency, masking, access, and retention requirements.
Less sensitive content, such as marketing drafts or general technical questions, can live in a more flexible zone that allows more experimentation. This distinction makes safe bring your own AI possible without pretending all data carries the same risk. With identity-aware routing, a senior engineer's question about a live incident can be handled differently from a new hire's question about general best practices.
Even with the right technical architecture, culture determines whether this works. Employees did not adopt AI tools because a policy told them to. They adopted them because the tools made work easier. If governance arrives only as a list of prohibitions, people will work around it.
Effective leadership starts by recognizing that experimentation has value. The goal is to give people channels that are safer and more coherent than today's ad hoc options, without destroying the speed and autonomy that made AI useful in the first place.
One practical move is to make the experimentation lane explicit. Offer sanctioned AI sandboxes and play areas with clear boundaries. Tell employees what data is allowed, what is strictly forbidden, and how to escalate when a workflow changes from an interesting experiment to something business critical.
Training should respect people's intelligence. They do not need another long lecture on how AI works. They need vivid examples of where organizations get burned, clear rules about sensitive data, and a short list of approved tools that are actually better than the random ones.
Human connectors also matter. An internal network of AI champions from different functions can act as scouts and translators. They can bring real use cases back to security, architecture, legal, and product teams. They can test whether policies make sense in daily work. They can also help move promising experiments into the governed lane before they become quiet dependencies.
Accountability still stays with people. Managers own the decisions their teams make, regardless of which assistant helped. Senior leaders own the organization's risk posture, regardless of which vendor model sits behind the scenes. At its heart, this topic is about who really owns your decision engine when AI tools are everywhere and mostly invisible. Treating LLM Roulette as a user problem leads to blocking, bypassing, and frustration. Treating it as a design problem leads to better questions. Where do we want AI in our decision flows? How do we make those touchpoints trustworthy, observable, and supportable? Which kinds of fragmentation are acceptable, and which undermine our ability to speak with one voice and stand behind our own work?
When leaders make that shift, board and executive conversations change. The discussion moves beyond paste restrictions and brand name tools. It becomes a conversation about decision quality, model behavior, data movement, and integration patterns.
Leaders start funding the integration work that makes governed paths smoother than workarounds. They also become more willing to say, "We do not allow this AI practice because it erodes trust in our outputs," and to back that up with design instead of warnings alone.
A useful starting move is simple and human. Ask your teams where AI already lives in their browsers today. Ask which workflows they quietly depend on. Ask what would make them willing to move those patterns into governed channels that still feel fast. Listen closely to the friction they describe. Inside those stories are the clues needed to move from roulette to architecture, and from accidental decision engines to ones the organization actually owns.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.